So we've just finished in number 10, I think. Find the acceleration. So let's look now when we're actually, the rope is being dragged at an angle like this. So imagine that there's a rope over your shoulder. You're dragging this object along. You're rarely going to drag it in a directly straight line like we've been looking at so far. So you're dragging it over your shoulder. So the tension is going in this direction here. And in this case, we're told it's 260. So I'm just going to take this triangle out for a second, where my tension is 260, which is my hypotenuse. I have an angle A, and I'm given some information about the angle A. Tan A is 12/5. Now, you can draw the triangle, or you could say tan is O/A, and sine is O/H. So sine is going to be 12/H, and the cos of A is going to be A/H, and you should identify this as the 5, 12, 13 triangle. If you don't, you can draw the triangle and use Pythagoras, but if you're doing that at this point of applied maths, then you know it's probably not a good sign that you have to do that at the beginning of a question. So what can we say then? We can get this and we can get this, these two lines here. So we can say that the cos of A is equal to, I'm going to call this one X and this one Y just for now. Cos A is equal to X over 260. So 260 by the cos of A is equal to X. And you can see that the adjacent, if you're practice teacher, you know the adjacent is going to be cos. So 260 by 5/13 is going to be 20 times 5. So 100 is equal to X, or we could say 100 newtons. I'm going to put in the N. 100 newtons is equal to my X, and my Y is going to be equal to 260 sine A. So Y is going to be 260 by 12/13, which is 240 newtons here and here. So once you have your forces, then everything else follows from there. So now let's just do our diagram again. We'll see what's going up, we'll see what's going down. In this case we have the cos, but we also have the sine here. So we have, this is 240, this is what we just calculated here. Going in this direction was 100. We have or going in this direction, and down this way we have mg, and the m in this case is 100. So 100g, 100 by 9.8, 100 by 9.8 is 980 newtons going down, and mu or going back this way, which they tell us, or do they tell us? Before we have seen that the arrow the wrong way around here, it's the force is going up. Actually, what I'm going to do is I will draw it above the line to match it off with or. Probably better maths to do it up here. That's my 240 and that way. So I have two ups and one down. So I think before getting the mu or going this way, I think I need to say the ups are equal to the downs. So or plus 240 is equal to 980. So or is going to be 740. And we could also say that, so let's look at left and right, just rub this out for a bit of neatness. Move my mu or down. So mu or has to be equal to 100. My left equal my right. And we have or, so we can say that mu by 740 is equal to 100. So mu is equal to 10/74. 5/37. Coefficient of friction, which I think is what we were asking this question. The coefficient of friction, and they do it the same way, 5/37. Okay, so let's have a look. In the next video, I'll just leave that one example here, and in the next video, because they're kind of back to the original early questions and these just dragging simple stuff along, we'll look at these 4 questions in number 11. Or 12, lost count.